Welcome to Module 2. So this Module 2 of Software Testing Foundation is dealing with software testing processes and testing types. Now you can see that development of software in general is composed of many activities. And these activities are varied from a software to another, a software project to another software project. But in general, these activities are comprised of requirement elicitation and then design and implementation. And then when you take the requirement and the requirement engineers are eliciting the requirements from the customers or from the users or from the stakeholders, they are forming the software specification document. And then this software specification document will be passed to the design team, and then this software design team will pass the design to the implementation, and then you implement the software, and then you can test it. Now these activities are differ with the software development process. So the software development process is basically the systematic way, the way that you are approaching the software development. Now a final product is a software product, but this software product is combination of many things like the software, the product specification, the product review, the design documentation, the feedback from previous version, or for the test plans and the customer survey and the software architecture are many other documents and other parts of this software. Now the software development model is the life cycle model of the software, how you start the development and how you divide the steps of the development until you release the software. So the life cycle model that is adopted for a project will have a significant impact on the testing. So which software development you are following will have an impact on your testing. So your testing will vary, your testing process will vary with the development process. The test activities are highly related to the software development activities, and we will see that later in these slides. The way testing is organized must fit to the software development process. Sorry. Now, we have very important activity which is called verification and validation in testing. And these activities are sometimes called V&V. Verification is the process of determining whether the product of a given phase of the software development process satisfy the requirement established during the previous phase. So you have phases of the software development and you verify each phase in the software development. But the validation is totally different because you verify the whole software from the starting to the end. So the verification is dealing with some part of the software or the software development phase. But the validation is about the whole process, the process of evaluating software at the end of the software development to ensure compliance with the intended usage. Now, sometimes you can see that they say independent or IV and V, which is like to indicate that the verification and validation are done by a different group or third party group, non-developer group, sometimes we say. Now, software development model, you have many software development model. Probably the most classical software development model is the waterfall model. Waterfall model is the classical software development model that split the software phases or development phases into parts or phases or an independent steps, and then these steps are done sequentially. So for example, you take the requirement and then the design and then detailed design and the implementation, and then finally you do the testing. This model starts with the feasibility study sometimes and follow down through the various project tasks, finish with the implementation into a live environment. Now, testing tends to happen towards the end of the project lifecycle. So this is a problematic situation as we defined later, as we defined earlier in module 1. So this means that always you discover a fault or the faults of the software at the end of the software development process. So it means like the cost of this fault will be the highest cost as possible in the project, which is kind of very difficult process. Now sometimes you can see that some textbook or new textbook are defining the waterfall model as a cylindric waterfall model, sometimes they say, which is the same, pretty the same, like you have the requirement, design, coding and testing, but you can um, compress it, and then you can see that from a top view. Then that is if you see that from a top view, then you can say that the testing is available in each space, in each level. But in general, the waterfall model is the worst model, but it is the classical it's the classical model of development. Now we have a V model, which is the modernization of waterfall model. The V model was developed to address some of the problems experienced using the traditional waterfall approach. The V model provide guidance that testing need to begin as early as possible. Now you can see that for each level of software development you have testing. So the V model is a model that illustrates how testing activities or V&V can be integrated into each phase. So you have each phase and you have tests for each phase of the development process. The activity should be carried out in parallel. Now you can see that when you have the user requirement, you can develop the acceptance testing, and when you have the acceptance testing, you can start this activity as early as possible. A good practice is to have testers involved even earlier during the review of the draft test basis documents. Another model of testing that we have is the W model. W model is kind of a modernization of V model, or double V model basically. Is the most recent software development model where we start real testing activities simultaneously with the software development process. V model covers the activities um, that is not covered by the V model, the W model, I mean. In the W model, there is no strict division between constructive task or the left-hand side, but you have the test starts when the project starts. The test program should be developed early and in parallel with the code. And that is the good things with the W model. You can see the graph of the W model, and you have like very intense testing during this model, that you have the test program, and then you have the code, and then you have the component and unit testing. So you have detail here. I mean, now we have another modern software development process, which is the iterative life cycle. The iterative life cycle define a new way of development, and nowadays in software engineering in big companies you have this kind of iterative life cycle model. It means like you are developing the software in an iterative way with a small portion, and then sometimes called incremental development model, instead of one broad development timeline from a beginning to the end, which is like the waterfall model. We cycle through a number of small self-containing life cycle phases. Now, the delivery is divided into incremental or builds, with each increment adding new functions. Now, the subsequent increment will need to test, and then you have a new term of regression testing, because every time you develop a new part of the software, you have already the other part, yeah, that you developed before, so you have to test them with the new part, and we will come back to this regression testing later. So we have this prototyping, we have rapid application development, which is called RAD or agile. So rapid application development is what we call the iterative life cycle. Sometimes we call rapid development application development is formally a parallel development of functions. Components of functions are developed in parallel as if they were in mini projects. So these mini projects, it means like you divide the whole project into small pieces, and each time, each iteration, you develop one part, and then it is very quickly giving a customer sometimes to see and use and to provide feedback very fast. So that's why you always have some product to show to the customer, and then you develop a small piece of that software, and it is kind of implementing some small function of the whole big function of the software. Validation with the RAD development process is an early as and major activity. Now, agile development also is kind of development that you have in software engineering, and it is also this kind of rapid development. You have a collection of term for many changeable process. Sometimes you have other terms also in agile, like XP, which is extreme programming. You can say that we have also Scrum and Lean and Kanban and many other new terms in Agile. But in general, these terms are Agile development. In extreme programming is currently one of the most well-known Agile development life cycle, and it is being used in many big companies nowadays. You promote the generation of business stories here. You have business stories, and then you have to define the functionality. It demand an on-site customer, so you have on-site customer every time the customer is sitting with your development team, and then you have the feedback from the customer from time to time, and this is very important. It promotes pair programming and share code ownership. It means like not only one developer is working on the coding, but there are two developers. One is sitting to code, and then one is watching him. So the component testing shall be written before the code is written, and this is very important. Here, the testing process is start as early as possible. XP developer write every test cases they can think of and automate them. Every time a change is made in the code, it is component tested and then integrated with the existing code. And then it means like you have still the same meaning of developing small software, and then you have to test these small pieces of the software until we reach something called integration testing. So this is incremental development that we said um, is the same meaning here, like the iterative or incremental life cycle. Then fractal development, also another term of development. It used the object-oriented development approach. You have every object is a small system as it is before, as we said, and then change the concept of testing because every part should be tested individually, and then this is what it is. Then you might say that, so what is a test process? So the test process should include the phases that exist for testing. So you have to define these phases, and you have to define the steps of testing within the software development lifecycle. If you do not write it, if you do not write the test case, the process of the testing, it is difficult to improve the process anyway, and it is difficult to improve the testing. Now, based on this, you can see that we have testing levels. A common type of V model uses different testing levels, and we can see that we are starting from the very beginning or the foundational level of the testing, and then we go up with the software. So we will start with the component, with the small pieces that we call the component testing, and then we build on these components, we integrate the component together to build a bigger piece of the software, and that is we need the integration testing. And then we build all the components together to form the software, and that is the system testing. And then finally, from the business point of view, you have to test the software for acceptance testing. So the component testing search for defect in the small pieces and verify the function of the software component. For example, the modules, the small pieces of programs, or classes of the program, or the objects of the program in the object-oriented programming. And then integration testing, when you integrate the small pieces, as we said, you test the integration of them, because you have to test the integration of these components. Sometimes the components, when you test the components are fine and you will not find bugs. But when you integrate them, the bug will happen during the integration, because two modules might not be compatible together, for example. Now, the component testing, or sometimes you say that unit testing, and unit testing basically is more famous nowadays. So search for defect in modules, in the small pieces that are separately testable, may be done in isolation from the rest of the software. So you pick up the module, bring it out, and then test it. Now the problem is, sometimes when you want to test a module, you need another module to be connected to this module, because this module cannot be work uh, alone. Then, but the other module is not available now because the developers are working on it. Then what you do, you need to define something called stub. A stub is a substitute of a module, just to make that module work. Then the stub and driver are used to replace the missing software and simulate the interaction or the interface between the software components in a simple manner. Typically, component testing occur with access to the code being tested, and then with the support of development environment, of course. And then here we have test-driven development. Sometimes it's kind of an approach in component testing. In agile, for example, is to automate the test cases before coding, and then you decide to prepare the test cases before coding, and based on these test cases you develop the components. Now, as we said before in the previous slide, we have this stub. This stub, now you can see this graph. We call this scaffolding. Scaffolding technique is the use of test harness. Test harness is usually implemented to facilitate the unit testing. So the test harness is like you have a set of test cases and you want to test a module. Here we call module to be tested. And then you bring out this module. It's a piece of code to be implemented inside a bigger software. And then you want to test only this piece of code. But this piece of code cannot be tested because you need like 2-3 other modules to be connected to this module, and then you can run this module. But these 3 other modules are not available to be connected to this module under test. So what to do here? You have to develop a stub. A stub is a small piece of code that just can play a fake role of the missing modules. And then you need a driver, like for example how to run this piece of code. And then for example you put this piece of code into some compiler to compile it and to execute it. And then when you have this, then you can run the test cases here. So the whole process is called the test harness, and then this technique is called scaffolding. Now integration testing is, as we said, is a testing for integrating the components. Now during the unit testing or the component testing, we test each individual component, but we need to integrate these components because software is typically is a combination of many components, many units. So now you tested each unit individually. Now you want to integrate them. The integration testing tests the interface between units or components interaction with different type of the software, such as the operating system, for example. The integration testing aims to detect defects that occur on the interface of the unit component to the assemble of individual units into working subsystem. So you have subsystem here, for example, in this graph, you have unit A, and unit A basically is a combination of unit A1 and A2. And you tested the A1 here with test 1A, and you tested unit unit A2 with test 1B, and then now you combine them together. So you have to test them again. And then that's why you have the driver code for unit A, and then you want to test them. And that is the integration testing. Now integration testing is kind of complicated when the software is getting complicated and complex. Integration testing can be performed using one of the following approaches. So you have different approach of integration testing. One approach is called the Big Bang, which means like you are testing all of them. When they are developed, each module is tested individually, all of them, and then this is kind of time consuming, of course. So when all the individual modules available, you test all of them, and then this will take a lot of time. You have another approach which is called bottom-up approach. The bottom level code um, are integrated step by step, level by level with the upper level, and then you test, and then with the upper level, and then we test, and then you integrate with the upper level until you get the whole system. And then you have this top-down approach, which is like you wait for the bigger modules, and then you don't need to wait for the small modules, and you replace the small module with stop, and then you come from top, you test them. And then you have this sandwich approach, which is combination of top down and bottom up, but this is also kind of very good for testing because it helps um, to exhaustively test the whole software in at many level, but this will take time also. It depends on how much time you have. Now you have the system testing after that level, which is concerned with the behavior of the whole system. Now you integrated the mod, you developed the modules, you test them, and then you integrated the module and you test the integration, and then you have a higher level, which is the system testing. The aim of system testing is to ensure that the system perform according to its requirement. And this is very important because now you have the software and you have the requirement and specification document, and you want to verify them. And then the system testing should investigate both the functional and non-functional requirement. And then we will come back to functional and non-functional requirement. Now, the system testing is complicated for software, and each software has a nature, and then it depends on the context of the software. And then basically, for example, for the software that are for the software that is highly dependent on database or data, for example, you need to perform volume testing because it's address the handling of large amount of data. And you have this stress testing, for example, to evaluate the system when it's stressed on its limit, for example, applying many users. What if the software is working for 100 users? What if I say that what about 1000 user, 1 million user, 2 million user, 1 billion user, for example? What will happen when you increase the number of users? So that is stressing of the software. You have configuration testing, different configuration of the software. What will happen when you test different configuration, when you test the software based on different configuration? You have compatibility testing. For example, a mobile application is working on a set of mobile, and it is not working properly on another set of mobile. So it means like you did not apply compatibility testing very well. We have regression testing. It is like retesting again and again for the same software with some development. You have security testing, you have timing testing, you have recovery testing, you have documentation testing, you human factor testing. There are many type of system testing. And finally, you have acceptance testing. This acceptance testing is very important because um, you now develop the software, you did the system testing with all these testing, and then you have now acceptance testing that is aimed to establish confidence of the system. Here, this user is very important, and it is kind of user-centric testing. So to see that whether the software is acceptable or not. So the client can evaluate the system either by conducting the following test cases. So you have, for example, benchmarking testing. Benchmark testing means like you have a system, you developed a system, and then there is another system which is look like this system, so you make that system as a benchmark and then evaluate the system performance against that other similar system. You have pilot testing, involve installing the system on an experimental base and then evaluate it against normal everyday work. For example, you install it on a simulator and then you simulate some test cases which are not real, but you simulate them to mimic, for example, the involvement of some data or the involvement of some user numbers and so on. Now you have alpha testing, which is what we called in-house testing. So it is kind of another kind of pilot testing, but inside the software team. And then finally, you have beta testing. Beta testing, you select a set of users or potential clients, and then you give them this software. After you perform component testing, integration testing, system testing, and then you give the software to a set of users or expert users or normal users and get them feedback. Normally it is being used with the companies or commercial companies. For example, we have seen that before with the beta version of antiviruses and so on. So that is what we have. And then we have testing types. Now, testing types, we have different levels, as we said, and then we have different testing types. Focus on particular testing objectives. So, what you want to test, for example. Now, the test could be the testing of a function to be performed or a non-functional quality characteristic, or the structure or the architecture of a component or related changes on confirming that the defects have been fixed. So for example, confirmers testing or retesting or whatever it is. So now, for example, the functional testing of the software is a type of testing. It's very important testing. It deals with what the software must do, and then the functional or the function of the software. You have to test the function of the software. The functional testing consider the specified behavior of the software, and it has been said that it is only useful for black box testing, but that is not true. Nowadays, functional testing is also useful for another type of testing, like white box testing, for example. Black box testing is also included in non-functional testing, for example. So we are passing these limitations for non-functional and functional requirements, non-functional testing, functional testing, and then functional testing, for example, you have requirement-based testing and you have business process-based testing. Now, the requirement-based testing is basically you are depending on the requirement document and then you elicitate the functions that the user wants and the user required, and then you want to test these functions based on that functional requirement that you have inside the software specification. And then the business process is basically using the knowledge of business process. This is kind of testing that you perform based on the knowledge. It's not available inside the document, but it is kind of business process that you have to do. For example, for employees or whatever it is inside the company, you have some specific cases that is not available in the requirement, but you have the knowledge of these tests of these cases and you want to test these cases. Now, non-functional testing, it deals with the non-functional requirement of the software. It is about how well the software or the system is working. Sometimes called testing of a quality characteristic, because quality characteristics are basically most of them are non-functional requirement and non-functional characteristics of the software. So for example, performance testing, load testing, stress testing, usability testing, these things are not tangible basically. A function is kind of, you have an addition function. You say that the function is 1 plus 1 equals 2. So the plus here is a function, but non-functional requirement like the stress testing, you want to test the usability, for example, the reliability, the efficiency, the maintainability. These characteristics are done by the testing. The non-functional testing like performance testing is done with the efficiency, for example. So when you do the performance testing, you are basically triggering the efficiency, which is the non-functional characteristic of that software. Now you have a lot of quality characteristics in the ISO 9126 standard, uh, and there are many others in the nowadays standards, new standards. Structural testing is often referred to white box testing or glass box testing, sometimes they say, because we are interested in what is happening inside the box. So it means like we are interested into the code itself. So here we have the code, and then sometimes you scan the code, you provide some test cases to this code, and you monitor a lot of things. For example, the code coverage. The code coverage measurement is a good measurement to see how much lines of code, how many lines of code you are covering while you are testing, for example. And that is one kind of, that is about the type of testing. Now we have the regression testing. Finally, this regression testing is very, very important because it is about dealing with the different version of the same software. Regression testing is very important nowadays in industry because you are having a lot of changes to the software, and you want to be sure that uh, all these changes are not affecting the previous version of the software or other part of the software. So you want to be sure that the changes to a particular application, a particular part of the software, does not negatively impact its correctness. For example, it is useful when performing maintenance. For example, when you fix a bug, you want to be sure that fixing this bug is not causing another bug in the software. There are two approaches of regression testing basically. We call retest all approach or selective retest approach. Now, retest all means like you have a software, you made, we call, you have a program, for example, we call that program P, and then you made a change in that program, we call that program P dash or whatever, and then you have a set of test cases called T for the original program, and now you want to see that the change, what you change. So you bring all the previous test cases, modify them, for example, a little bit, and then you bring the T, which is the previous set of test cases, and then you identify what you change in the software, what you add, for example, to that software, and you develop a set of new test cases we call delta T. And then we combine the previous set of test cases and this new set of test cases for the changes that you did in the software, and both of them you apply for program P dash, and that is retests all approach. You want to retest the whole software with the changes that you made. But another part, I have to say that this retest all approach, sometimes it's time consuming. So for example, you have 2000 test cases and you want to change the program a little bit, you add two more test cases, for example, you have to run 2002 or more than 2000 test cases every time. Imagine that if one test case costs you like 1 minute, and then you have to wait 2000 minutes every time to test all. So this is kind of not clever. Another clever way is to selective retest. Selective retest means like you want to identify those changes, those changes you did in the program, and then you want to only test those changes and those impacted part inside the software, and then keep the other part because you tested already and you don't need to retest them all again. And then here you have the program and you have the new set of test cases. These new set of test cases were identified by something called change impact analysis. You just want to test only those affected parts. So for example, here you have this program, and then you did some changes. You added major software function 2, yeah, 3, for example, and then this major function 3 is affecting code unit 2, and then major function 2, for example, and then these three parts should be tested. Only these three parts should be tested. So these are the affected parts of the software. And then the problem here is having this change impact analysis is not easy, because you need a careful design of change impact analysis strategy to see. Sometimes you put a lot of tracing inside the program and to see that which part has been changed in the program and then which part has been affected by your change. And then this is not easy, but it is very effective, and then you will save a lot of time in your development team. So that is basically the module 2, about the testing type and testing level and testing process. Thank you very much, and see you in module 3.